Hello and a very warm welcome. Back on June the 4th of this year, 2020, I published a video entitled A Question for Gravity-Denying Flat Earthers. Why does water find its level? And in that video I asked for flat earthers and anybody else who thinks that gravity doesn't exist to respond to simple question, why does water find its level? And in particular, the demonstration that I did with this water level. And I've waited, and there were a few things in the comments, but nobody came up with a response until now. And YouTuber Brian's Logic has published a video responding to my question. So let's have a look.
Hey, this is going to be a response to Miles Davis's video, A Question for Gravity-Denying Flat Earthers. Why does water find its level? Question mark. Okay, for a start, I don't, as a flat earther, I am 100% convinced that it's down to relative density equilibrium is the reason why things go down and things go up. We don't just have one vector, which is a downward vector. We have a downward and an upward vector. Okay, all things more dense than oxygen, I just use oxygen as the benchmark, all things more dense than oxygen will go down through oxygen and sit below it naturally, whether it be fluid, liquids, solids, or other gases that are more dense. So gases that are more dense than oxygen will sit below oxygen. All matter that is less dense than oxygen will rise above it, okay, including nitrogen, which is less dense than oxygen, just slightly less dense than oxygen. So nitrogen sits slightly above oxygen in our atmosphere. Nitrogen sits slightly above oxygen in our atmosphere.
Yes, I heard it correctly. And so did you. Oh boy, I hope it's not like this all the way through his video. But you better get those oven mitts out and push the monitors back, as Blue likes to say. This is going to be fun. So we were just about a minute into Brian's video when he said this.
Nitrogen sits slightly above oxygen in our atmosphere.
So the next part of Brian's video, he talks about oxygen, things less dense than oxygen like nitrogen floating above it, things more dense than oxygen sinking down through it. And he goes on to make the absurd claim that this is what happens in our atmosphere, and then follows this up by saying that although this happens in our atmosphere, all the gases get mixed up by the wind. This is another false statement, but let's listen to it.
In our atmosphere, they're mixed by the wind, right? So when you're sitting inside in a house and the windows and doors are all closed, you're sitting in there and things feel a bit stuffy, you're not getting the correct mixture of oxygen and nitrogen.
No, Brian, that's not how it works at all. Atoms and molecules in gas have something called thermal velocity. The thermal velocity of molecules of gas in the air is around 464 meters per second. That means that every molecule whether it's an oxygen molecule, nitrogen molecule, an atom of argon, carbon dioxide molecule, every molecule is moving around at around about 464 meters per second, flying around in all directions. Now, some of the molecules will go faster. This is an average speed, and some a bit slower than that. So when a molecule collides with another molecule, or it collides with the surface, it will lose a little bit of that kinetic energy. But when it is heated by something, a radiator in your room, the sun outside, then it will gain a little bit more energy and its speed will increase. The molecules are whizzing about in all directions all the time in the air, and therefore they are mixing up with each other. They will also be subjected to the acceleration due to gravity, a single downward acceleration, but that acceleration is tiny by comparison to the nearly 500 meters per second that they are moving around in other directions.
When you go outside, if there's a bit of a wind blowing, especially, you get this uplifting waking up effect that happens because you're getting the correct mixture all of a sudden, and it's being mixed properly by the wind. So on a day when there isn't enough wind blowing, right, if it's a very still kind of a day, especially if it's hot, then it can be, you'll feel sleepy sometimes because you're not getting the correct mixture of oxygen and nitrogen.
I did warn you to get the oven mitts out. Brian, let's consider what would happen in your explanation if you were to sleep for 8 hours. According to you, the oxygen would settle into the bottom 21% of the room, and the nitrogen would occupy the remainder of the room. We can ignore the trace gases for now. Now, the rooms in my house are 2.6 meters high. So this means that the oxygen would occupy 52 centimeters or thereabouts at the bottom of the room. My bed is, the top of the mattress is 58 centimeters from the floor. But when I'm lying on the mattress, my nose and mouth are probably well over 60 centimeters from the floor, which means I will inhale pure nitrogen, according to you. Do you know how long you can inhale pure nitrogen without dying? It's not very long. I would pass out immediately, and because I'm lying on my bed, I would not fall into a higher oxygen concentration, and so I would die pretty quickly from lack of oxygen. Have you ever done this? Have you ever experienced suffocation at night because you fell asleep? No, me either. Maybe you got this wrong, Brian. So Brian continues to witter on about oxygen and nitrogen gases for a bit, and then he says this.
Especially if you have a fire in your house going or something like that, then you're causing oxygen, the oxygen indoors, to change its density and rise. So what actually happens is you end up breathing in more nitrogen than oxygen if it's sitting in where there's a fire, and because of this lack of oxygen, you start to fall asleep. Right, that's what happens, right? But in an ideal setting where there is wind and all that blowing, you get the outside, you get the right mixture of both. But oxygen and nitrogen are two different densities. Nitrogen is less dense than oxygen, right? So oxygen sits below it. Now, why does oxygen sit below nitrogen?
Listen very carefully. I shall say this only once.
In Earth's atmosphere, oxygen and nitrogen are always mixed in the ratio 21% to 78%, whether you're indoors or out.
Just because it's more dense. Why? What causes something that is more dense sit below something that is less dense, or something that is less dense sit above something that is more dense?
Oh, great. At last we're going to get on to Brian's explanation for the little demonstration that I showed in my video.
Well, the reason is structural support.
Okay, I didn't see that one coming. I wonder where he's going with this.
If you want to support something structure, then you are going to have the adequate support, the adequate support for that, for the weight of that, and for the density of it, basically.
Yes, very much, Brian. Weight is a force caused by the gravitational attraction of the Earth. You're supposed to be dealing with my demonstration without using gravity. If you use the word weight, then you are using gravity as your explanation. And we know that gravity provides a really good, simple explanation. You can't just change the definition of the word weight to suit yourself. This is what weight means. So I hope you don't use it again.
That's why we build with concrete, because it has, and steel within the concrete, because that has such density and strength that it has the structural support for massive amounts of concrete and steel on top of it. It's structural support. That's why and density that's all it is. The relative density equilibrium is about structural support. So the least dense thing that matter that I know of is hydrogen. The second least dense that I know about is helium. So hydrogen sits above helium because helium has enough structural support, right, for the hydrogen, right. In general, right, in ideal circumstances, the helium can support the hydrogen because of it has enough density to give it enough structural support for the hydrogen.
Oh, Brian, we've been through this. Hydrogen and helium are both gases. The molecules in a gas have thermal velocity. And that means the molecules move around and the gases mix together.
Helium won't support oxygen because oxygen is too dense, right? But oxygen can support helium, right? It's structural support, and the same happens in our world, right? Right? Rock and clay can support water, let's just say, right? It can contain water, right? It has the support for water and liquids, right? It has enough density to hold the water. So, you know, everything is about structural support, right? If you think of relative density equilibrium in terms of structural support and look at it that way, it makes far more sense, right? So structural support is the reason why things are the way they are. That's why the water in the tubes won't go up, because the air in the tubes, right, let's call it the gases, right, the liquids won't go up, right, above the gases, because the gases don't have structural support for the liquids. That's the reason. They can't support the liquids. Now, when it comes to buoyancy, that's different. That's volume, area, design, and displacement, not buoyancy. It's flotation. There's no such thing as buoyancy. There's no such thing as gravity, and there's no such thing as mass, right? Matter exists.
Oh, for goodness sake, there you go, making up definitions again. Matter is anything that has mass and takes up space or has volume. You can't say there's no such thing as mass and then in the same sentence say there is such a thing as matter. They're the same thing, Brian.
Relative density equilibrium exists, and volume, area, design, and displacement exists. But buoyancy, gravity, and mass does not. Right? And until you get rid of the idea that any of those three do, then you're always going to be trying to prove a negative, right?
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. May God have mercy on your soul.
Well, I don't know about you, but I'm starting to wonder whether Brian put his video together as some kind of spoof or joke. Either that or he's never bothered to use a search engine on the internet. I've shown a lot of his video up to this point, and there's an awful lot of it left. So I hope you'll forgive me if I simply skip a lot of this rather difficult to follow rambling about structural support and density equilibrium and all the other stuff he says. I'm just going to pick out the bits that I think give the most amusement value.
Because there was more of it, right? So I had more weight. Now, what gave it its weight? Why did water have weight? Well, it has weight because of density. Any solid object, an object's weight is defined by its inherent density within its volume. So the amount of matter that exists within the confines of the volume of an object will define the amount of weight it has. Because the square cube of steel has more weight because it has more density. For a start, you'll have to get onto the correct gravity, because it's not a force, even though Miles states it in this video as a force.
While you're reading this more detailed definition of weight, I would like to point out that at no point in my video did I say that gravity is a force. I said that gravity is a downward acceleration towards the Earth, and it is that downward acceleration that creates the force called weight. Okay, so let's deal with this statement: gravity is not a force. Gravity is the curvature of space-time by mass. The result of that curvature of space-time is that objects with mass acquire a force called weight. A 1 kilogram mass here on Earth has a different weight to a 1 kilogram mass on or near to the Moon. A 1 kilogram mass at sea level on Earth has a different weight to a 1 kilogram mass high above the Earth. Weight is the force. As it says in this definition, weight is the force that results from the acceleration by gravity on the mass of an object. Weight equals mass times gravity. If you want to explain my observation, you have to stop using the word weight and educate yourself about what gravity actually is.
So it's very obvious what's causing the weight. Weight is caused by density. We know density gives things weight. So there was more weight on the right side here than on the left. So once he released the clip here, it allowed the water, right, which is free flowing, free moving. It's a fluid, right? So it will fill any shaped container, and because there was more weight due to more water over here, it forced itself down until it equalized and forced this water, so this side up, the water in here to come up and push up the air that's less dense above it, push it up out of the way, right? The same way as a rock will, we throw a rock into water, it'll displace the water, right? So the water displaced the air or the gas. The liquid displaced the gas. That's what happened in this situation.
Brian, thank you for restating what my demonstration showed, but you're supposed to be explaining it without using gravity or weight or saying things are heavier, because that's all part of the gravity explanation. You're supposed to be giving me an explanation, not restating what I showed.
Now, how can Miles or anyone else prove that gravity causes an inch cubed of steel to be heavier than an inch cubed of wood? You've got to show that that is not density.
Actually, Brian, that is density.
And it's an impossibility to show that that is not density when it obviously is density.
Yes, Brian, no disagreement from me. That is density. Density is mass divided by volume. At least you got one thing right in this video.
And it's not the density, right? Density is what causes the weight. You have to prove first, Miles, because I'm sure you'll see this, how weight is caused by gravity. And there's no point in giving me equations. You have to give me proof that gravity causes weight.
Well, no, Brian, not really, because what I did was show a demonstration. I then gave the gravity explanation for that particular demonstration or observation. And I asked whether you could provide, or whether anybody else could provide, an alternative explanation. An alternative explanation, hopefully that was as good as the gravity explanation or better. So far, you've failed to do so.
Although gases can't be weighed unless they're put into a container, right? You can weigh them, but you have to put them into a container. But they can be weighed in that way. Right? Anyone on the globe side, you've got to prove that weight has been caused by a force or an effect.
Weight is a force.
Right? Now, at present, it's an effect. The force is out the window. Right? But you've got to prove that there's some other thing besides density. Basically, the main question is, you've got to prove there's something besides density that's causing weight. Right? I don't know how you're going to do that.
So once again, you're misrepresenting what I was saying. I presented the gravitational explanation for the demonstration that I did, and I was asking other people to come up with alternative explanations so that we could compare those explanations and see whether they better fit the demonstration that I did, and maybe whether they better fit other demonstrations as well.
Right? In Miles' video, he states a couple of times that gravity is a force. Now,
I really don't think that I did say that. I certainly didn't mean to say that. What I meant to say, and what I think I did say, is that there is an acceleration due to gravity, due to the curvature of space-time, and that acceleration results in the force that we call weight. So the last section of Brian's video is not really related directly to my observation, but once again, Brian reveals his ignorance of things to do with liquids, gases, chemistry, bonds, and so on. So I'll play a couple of little bits from that section as well.
we have this situation here where someone, I think it was a lady, made this diagram, okay, and she's in something to do with some kind of field of science, right? And right, she's still, I'm not going to talk about all of them, just liquid and gas. right? Liquid, right? The molecules that make up a liquid, right, flow easily around one another. They are kept from flowing apart by, here's what she says, attractive forces between them, right? Liquids assume the shape of their containers. Now, liquids assume the shape of their containers. Yes, that's correct. The molecules that make up a liquid flow easily around one another. That's correct. But this part is not. They are kept from flowing apart by attractive forces. That's not correct.
Actually, Brian, it is true. There are a collection of intermolecular bonds that are also known as intermolecular forces. They tend to be called intermolecular forces because they involve an electrical attraction between positive and negative parts of molecules or ions within a liquid.
Right, she's inferring a force of gravity there, something that's been out of date since 1915.
Brian, there's no inference of gravity here. Intermolecular forces, intermolecular bonds are well known, well understood, well described. They're taught to children at high school as well as in a more advanced way, I'm sure, to students in universities. Why do you think that diagram was inferring gravity?
She's inferring this into water and why the molecules stay together. The reason that molecules stay together, of liquid molecules stay together, they do move around, but the reason that they stay together and don't do what gas does is because they have intermolecular bonding. Right?
Well done, Brian. That's absolutely correct. These forces, also called bonds, we have hydrogen bonds, dipole bonds, and things called London dispersion. They tend to be called forces, not bonds. So you're simply misunderstanding what the diagram is talking about.
Which means the molecules are bonded together. So if you can imagine them as like little molecules with little chains between them, right, as a visual, right? So they can move around, but they're all connected by these chains.
I don't think it's very helpful to think of them as being little chains. They are temporary attractions between the molecules caused by usually a difference in the electrical charge on different parts of the molecule. And that attraction can form and break repeatedly, and that's why the molecules and ions are able to move.
Or everywhere they go, they can move around, but they're connected by these little chains or little connectors, right? That connects them. If you want to see it in a visual way, right? Right. So then we move on to gas, right? So first of all, she's wrong, completely wrong. The person that made this, right? But she was taught gravity was a force of attraction between masses as well. So she's adding in this force of attraction between masses into this thing to do with liquid. Liquid, it's got to do with intermolecular bonding, right? That's why the molecules in liquids, right, stay together, right? They move around, right? They fill any shaped container, not like a solid, but they they're still bonded together. Then we move on to gas. For gas, she says, the molecules that make up a gas fly in all directions at great speeds. Yes, right? That seems to be exactly what gas does. They are so far apart that the attractive forces, here we go again, between them are insignificant. No.
Sorry, Brian, but yes. As we saw earlier, gas molecules have thermal velocity. They have a lot of kinetic energy. They're whizzing around very, very fast indeed. That kinetic energy is sufficient to break these attractive forces between them. And because they're moving around so quickly and because the space between the molecules is so much greater, the attractive force between the molecules in perhaps a dipole-dipole situation is simply too weak to actually bring those two molecules together, and they continue to move apart or just carry on moving. What she's stating in her diagram is absolutely correct, and she's not inferring gravity at all. So Brian completely misunderstands what the diagram is actually referring to when it talks about intermolecular forces. It's referring to electromagnetic attraction between molecules because different parts of those molecules carry a different electrical charge. And that charge, that irregularity in the charge can be temporary, and the bonds that form between the molecules are very temporary, if you can call them bonds at all. They are an electromagnetic attraction between negatively and positively charged parts of the molecule. In a gas, those kinds of electrical disparities between parts of the molecule can still occur, and the attraction between negative and positive, or delta negative and delta positive parts of the molecule would be exactly the same as it would be in a liquid. The difference is the molecules are spaced further apart, so the attractive force becomes insignificant, and the molecules also have far more kinetic energy. They're whizzing around far faster. So in the rare event when such a bond would form, it would break almost instantly, and the effect would be negligible. So Brian continues to basically rant about this for quite a while without really saying anything terribly useful. He says some things that are correct and some things that are completely wrong. And then finally, he actually goes back to addressing my demonstration. So let's see if he actually comes up with an explanation, because we're nearly at the end of this video and I've yet to hear an explanation for what I demonstrated or what we observed, and certainly no explanation that uses something other than gravity. He's invoked weight repeatedly, and weight is simply another way of talking about gravity.
Miles wanting to know about why does water find its level? Because why does water find its own level? Because water is always has to be contained, and basically there's no, it's down to weight. If there's more water in one place on one side of a lake than the other, then it's not going to be up one side down. The extra volume of water is going to push down and on one side and push up on the other, just like in your diagram here, Miles, or in your demonstration here, Miles. One side, the heavier side, is going to push down and equalize with the less heavy side, and it's going to displace whatever gases or whatever is in the way, right? And there's less dense, it's going to be displaced. That's what's going to happen. But what causes the weight? Density. So I hope this answers the question. Thank you. Bye.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. May God have mercy on your soul.
So if you've got this far, well done. And I hope you enjoyed what you've seen. I've been a little bit harsh on Brian, and the reason I've done that is the exchange that you can see on the screen at the moment. This morning I received a message from Brian in the comments section of one of my videos, well, the video that he's responding to, which said that he'd made a response. I replied, honestly, I've only listened to the first minute of your video and you've already made a number of demonstrably false statements. So I'll give you a chance to take it down and maybe try again. If you leave it up, I will probably feel the need to make a response video pointing out some of your mistakes. Brian responded pretty quickly, Miles, I'm fully confident and aware of my statements and words in this video, so you are welcome to make a response video. He says, I didn't get anything wrong. He says, you're spelt incorrectly. That should be U apostrophe R-E. The person in your video stating gravity is a force. I welcome a reply, "It's fine, Miles, just go with it." I think Brian is a very fine example of the Dunning-Kruger effect, where somebody with relatively little knowledge of a subject seems to think that they have a great deal of knowledge about a subject. It's not a problem to have little knowledge about a subject. We can't all be experts in everything. I'm not an expert in physics. I'm not definitely not an expert in gravity. I think I understand gravity well enough to be able to explain things that I observe in a fairly good way. I understand some of physics, but not a great deal. I understand chemistry a little better, and biology a lot better, because I spent my education and my career studying biochemistry and cell biology and molecular biology. I would never claim to be an expert in physics or even an expert in chemistry. But Brian, you seem to be thinking that you have a greater deal of knowledge about physics, chemistry than I do. And I think we've just seen that that is definitely not the case.
Tequila!